these are the notes for section 5.6, and it's not part 1. We're actually just going to do 5.6 all at once. So this section is called factoring, sums, so that's adding, or differences, so that's subtracting, of cubes. So you might remember in the past, and what I'm about to write in red, you don't have to write down, but you can. We have factored, oh, it's supposed to be red. We have factored a difference of squares before. So that was when we had something like a squared minus b squared, and that ended up being a plus b times a minus b. So when it comes to things being squared, a squared, b squared, only a difference worked. We could only factor it if it was subtraction. If it was a squared plus b squared, we couldn't factor it. Now when we do cubes, we're going to be able to factor it whether it's a sum or a difference. So if it's a cubed minus b cubed or a cubed plus b cubed, we're going to be able to factor it either way. So now I'm about to start writing in green, and you do need to write this down. So what I'm about to write is the general formula for what happens when we do a sum of cubes. So if we have something cubed plus something else cubed, we can always factor that into the first term plus the second term, so a plus b, times a squared minus ab plus b squared. So you'll notice that second set of parentheses looks really similar to when we factored a squared binomial. And I know it's going to seem tough to memorize this, but you do need to memorize it. But you're going to do so much practice that hopefully it'll just kind of naturally be memorized rather than having to like stare at it on a flashcard. But I would recommend, honestly, try to write it down over and over without looking until you've got it. So two things I always keep in mind are that this sign is the same as this sign. It's up to you if you want to write this or not. And this symbol is the opposite of this symbol. So that's how I keep my signs straight when I try to remember this. So that's a sum of cubes. Now a difference of cubes looks very similar. If we have two things cubed that are subtracted, we can always factor that into a minus b times a squared plus ab plus b squared. And this rule I said with the same sign, opposite sign, you'll notice that still works. Same sign in the first set of parentheses, and then this sign is always opposite of what you had in the beginning, and then this last sign is always a plus. So those are just some tricks to remember those signs, but these two kind of formulas for how to factor a sum or difference of cubes are very, very important, and you have to know them. Like I said, hopefully we'll do enough practice that you just kind of know them anyway. One thing we might want to write down before we start factoring these is a list of cubes. So we're going to just write a little list. I just did this onto the side of my paper of values of n and then the cube of those numbers. So let's start with the decimal. If you do 0.1 times itself 3 times, you get 0.001. If you do 0.2 times itself 3 times, you get 0.008. And now let's move into our whole numbers. 1 cubed is 1. 2 cubed is 8. That means 2 times 2 times 2. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. And 6 cubed is 216. All this, memorize. Yay! Make flashcards if you need to. Alright, so now I just have 1, 2, 3, 4 factoring examples and 1 to try on your own. Alright, let's get started with the first one here. So let's start with this pretty simple one here. I want us to factor x cubed plus 27. So as we go through here, we want to start noticing as soon as we see this that 27 is a perfect cube. So we're going to write this kind of like I did our sum and our difference of squares. X to the power of 3 is x to the power 3. I know it seems silly to write that, but they're going to get more complicated later. And 27 is 3 to the power 3. So this is a sum of cubes. So remember our rule is that if we have a cubed plus b cubed, it factors into a plus b times a squared minus ab plus b squared. That's in that first, I think I wrote it in green box that you had to memorize, or you have to memorize at some point. So right now we've got x cubed, so that's kind of our a is x, and 3 is our b. So when we factor this, we have to do a plus b, so that's x plus 3, times a squared, so that's x squared, minus a times b, so that's x times 3, but we don't write x times 3, we write 3x. So 3x plus b squared, so plus 3 squared, which is 9. 3 squared is 9. That's it. You'd want to look at both of those and make sure you couldn't factor them anymore. When I look at that second set of parentheses, I can't think of anything that multiplies to positive 9 and adds up to negative 3. So we're done factoring. That's it. All right, 3 more. Now we are going to factor m to the power, oh, sorry, I just skipped one. Not m. 125 x to the 3 minus y cubed. So at some point, we want to get to where we can look at this and think, hey, I think that's a difference of cubes, because I see these two numbers, these two variables cubed, the x cubed and y cubed, and 125 is a perfect cube. Because if I wanted to get 125x cubed, I could take 5x and cube it, because 5 cubed is 125, x cubed is x cubed, and I would get back to that term. And then y cubed is an easy one. That's just y to the power 3. So now I can see I have a difference of cubes here. My a is 5x, my b is y, and here's my formula in case we don't know it yet. If I have something cubed minus something cubed, a difference of cubes, that's going to factor into a minus b times a squared plus ab plus b squared. Again, that's from that green box in the beginning that we've got to memorize. So I'm just going to be plugging in my a and b now. So a minus b, that's 5x minus y. You know, I'm going to move this over because I'm not going to have room here. Sometimes these take up a lot of room. So I'm doing a minus b is kind of starting over here. 5x minus y. And then I've got a squared, so that's 5x squared. I'm going to write that out right now. If you already know what 5x squared is, you can write that in there. I just want to show you what I'm doing. Plus ab, so I'm here right now. So 5x times y, that's just 5xy. I'm just multiplying those a and b together. Plus b squared, so plus y squared. So now let's go ahead and just write out what that 5x squared was, because I didn't do that in the beginning. So I've got 5x minus y in this first set of parentheses. And here, 5x squared, 5x times 5x is 25x squared. And then plus the 5xy plus y squared. The rest of it's already multiplied out. And I think we're done. I mean, we'd kind of want to check if we could factor that last part out again. It looks like it could be a squared binomial. But if because you know, I'm seeing right now that this is actually 5x squared, and this is y squared, and then I think, okay, is this middle one 2 times 5x times y? And the answer is no. So I can't factor anymore. This is just my answer. I'm done. All right. How many more? 1, 2. I think I said 3 more last time, but I was lying. We still have 3 more. Whoops, sorry. All right. Don't do that. All right, so we are going to now factor m to the 6 plus 64. This one's not as obviously a sum of cubes because of that m to the 6, but I see the 64 and I know that's a perfect cube because I know that 64 is 4 cubed. So we want to think if we can write m to the 6 as a cube. So remember, a power to a power, we multiply the powers. So if I do m squared and cube it, that's the same as m to the 6. That's the same thing. So this is a sum of cubes. It's m squared, that's my a, cubed, plus 4, that's my b, cubed. So here's my formula. If I have a cubed plus b cubed, it factors into a plus b times a squared minus ab plus b squared. That's what we got to memorize. That's from that first green box. All right, so let's write this out. First, I've got a plus b. So this is m squared plus 4. That's a plus sign right there. Sorry. And then I've got to write out this set of parentheses. So a squared, so I'm doing m squared, that's my a, and squaring it, I'm doing a squared, a is m squared, and I have to square that, minus ab, so minus m squared times 4, but I write 4m squared, right? 4m squared, plus b squared, so plus 4 squared. Now, if you wanted to if you knew what m squared to the power of 2 was, right there, and what 4 squared was, you can write that out in the beginning. I just want to show you what I'm doing. So let's see. Let's simplify some of that. So m squared plus 4 is my first set of parentheses. If that had been a minus, that would have been a difference of squares, wouldn't it? And I could have factored it, but it's a plus, so who cares? All right, and then m squared squared is m to the 4th, because I did 2 times 2, minus 4m squared plus 4 squared, which is 16. So I just squared those ones that I didn't square before. And I think I'm done. Again, I could check if this is a perfect square binomial, but it's not. I can just look at it and tell because m squared and 4 are the square roots of these. And if I do 2 times those times each other, I'm not going to get that middle term, so it doesn't work. Okay, 2 more. Let's go. Alright, so next, let's get it a little more complicated. We are going to factor 128 y to the 7th minus 250 x to the 6th y. So when I look at that, I think, these are not perfect cubes. So it looks like it's not going to work. But remember, our first rule of factoring, no matter what, is always to factor out common factors. Always, always, always. So if I look at those two numbers, we could check if there's any bigger numbers that go into them. But I know right now that 2 goes into both those numbers. So I'm going to factor a 2 out, and then maybe we'll see if we can take more out. So I can take a 2 from each of those numbers. I can divide them. And each of those terms has at least one y that I could take. So I'm going to take a y out. And then let's write what we have left. So 128 divided by 2 is 64. And I took one of those y's, so he's left with 6 y's instead of 7 now. Minus 250 divided by that 2 that I took out is 125. He still has the x to the 6, but we stole his y, so that's it. So now this part I have in parentheses, the 64y to the 6 minus 125x to the 6, that's looking a lot nicer because I'm recognizing that both those numbers are cubes and both of the powers, the 6's, those are both multiples of 3, so I think I can make them look like cubes. So keep in mind that we always don't want to forget about this 2y that we factored out. That has to be part of our answer. You can't leave it behind. Now let's try to write this guy out as cubes. So 64 is 4 cubed, and I can do y squared, and if I cube that, 4 cubed is 64, and y squared to the power of 3 is y to the 6th, what I started with, because you'd multiply 2 times 3. And then minus, let's see, this guy is 125 is 5 cubed, and again, I can take x squared and I can write that as a cube because I would just multiply those powers 2 times 3 and it would get me back to 6. So these lines are exactly the same. I just rewrote that guy in blue parentheses as a difference of cubes. Actually, technically I should have one more set around here because that 2y is being multiplied to everything. So when I'm factoring this, here's what I would do. Write down the 2y because we don't want to forget that he's out there. And then we have a difference because it's a minus in here. I'm looking at here now. We have a difference of cubes. So remember, if we have a cubed minus b cubed, that factors into a minus b times a squared plus ab plus b squared, and I'm running out of room over there. So here's our a, 4y squared, that's our a, and here's our b, 5x squared. So now let's factor that. So first I've got to do a minus b, so that's 4y squared minus b, which is 5x squared. Ooh, that was almost a difference of cubes, but that squares, sorry, but that 5 is not a perfect square, so we're not going to factor that anymore. And then I've got, and now I'm doing this part, I've got a squared, so that's 4y squared squared, 4y squared squared, because my a is 4y squared, and I have to square that because of that guy, plus ab, I'm doing that part now, so plus 4y squared times 5x squared, whoops, x, 5 has an x with it. And then at the end I have plus b squared, so plus 5x squared squared. Oh goodness, all right, this is humongous. Let's go ahead and just simplify it a little bit. So I've got my 2y sitting out front, that's the same. This first set of parentheses is fine. 4y squared minus 5x squared. And then now let's simplify this part out. So 4y squared squared, that's 16y to the 4th, plus, now I'm going to multiply this out. So 4 times 5 is 20, and it's got an x squared y squared. And then last here, I've got 5x squared squared. So remember, I squared both of those. So that's 25x to the 4th. And we are done. My goodness, that was a big one, wasn't it? All right, I'm going to do one more super fast because I'm recording this in the morning and you guys are all coming into school right now, so I have to do it fast. Okay, so last one. This is a big one. We are going to factor r to the 6 minus s to the 6. So one thing I want you guys to notice is that we could write this as a difference of cubes right away. We could write this as r squared cubed minus s squared cubed. This is a difference of cubes. Now, I was going to go through and do this with you, but I'm running out of time. So I want you to know that if you do that, you're going to end up with something that can be factored more, and you're not going to realize that it can be factored more. You wouldn't get it all the way factored. It would kind of stink. You'd get it wrong. So here's the rule. We can also write this as a difference of squares. We can write this as r cubed squared minus s cubed squared. So if you're ever faced with a choice, if you can write it as a difference of cubes or a difference of squares, start with the difference of squares and then factor in more. That's the general rule. Start with the difference of squares. Oh no, I have to hurry. All right, it's 8:30. All right, so remember a difference of squares, a squared minus b squared. We factor that into a plus b times a minus b. So that's what we're going to do first. Here's our a, it's being squared. Here's our b, it's being squared. So we've got to do r to the 3 minus s to the 3 times r to the 3 plus s to the 3. That's just factoring a difference of squares. Now look at what we have. Both of these are a sum or difference of cubes. Here's a difference of cubes. So that's going to factor into r minus s times r squared plus rs plus s squared. This guy is a sum of cubes. That's going to factor into r plus s times r squared minus rs plus s squared. Yeah, I know, that one was crazy. We can ask questions about that tomorrow if you have them. And I have one for you to try. Let me get it written down really quick. So I want you guys to try and factor, this one's not too hard, y to the 7 minus y. Remember, factor out a common factor if you can. All right, come with questions.